Hey guys, we're going to be talking about the exponential function, okay? So an exponential function is in the form of y equals a times b to the x. So we would say this is the standard form of it, okay? Now, a does not equal 0 because otherwise it would just be y equals 0. B, we are assuming is positive, all right? And by that I mean b is greater than 0, okay? Now, you could say you have a negative b, but we don't actually attribute that negative sign to b. So like, for example, you could have something like negative 3 to the x. But then we wouldn't actually say that b is negative. We would say a is a negative 1 times 3 to the x. Okay, so just be aware of that. Okay, so when it says right here, b is greater than 0, yes, you might see something that looks in the form of this, but we're not saying it's a negative 3. We're saying it's a negative 1 times 3 to the x. Okay? Excuse me, sorry. And we assume that b does not equal 1 because 1 raised to any number is x. And the exponent, this is what makes an exponential function exponential. The exponent must be a variable, okay? So a lot of times students see something like this. They see x squared and they're like, oh, that's exponential. No, this is quadratic. 2 to the x is exponential because the exponent is a variable, okay? So what does the graph of the exponential function looks like? Well, it all depends on if b is less than 1 or if b is greater than 1, okay? So first, let me show you a graph where b is assumed to be greater than 1. So I'll show you the example of y equals 2 raised to the x. So in this case, I'm going to show you 2 is your b value, okay? So, exponential functions, unless there's a shifting up or down, always start at the point 0, 1, okay? Exponential functions, unless there's a shifting up or down, cross the y-axis at 0, 1. All right? Then, it's also important to realize that we actually have an asymptote, okay? We have an asymptote at the value y equals 0, okay? Let's talk about why we have this asymptote. Why do we have an asymptote at the value of y equals 0? Why is this a thing taking place? Okay? Well, let's take this example. Y equals 2 raised to the x. So if we wanted y to be 0, so we'd say 0 equals 2 to the x. So what x value could make this happen? In other words, what is a number I could plug in for x, such as if I raised 2 to that number, I would get 0, an output of 0. What is this number? What would this number need to be to make this happen? Hopefully you're like, nothing? Because it doesn't exist. A lot of students make the mistake of saying 2 to the 0. They think, oh, if I raise it to the 0 power, that'll give me 0. No. Anything raised to the 0 power is 1, okay? So 2 to the 0 is really just 1. There is no number that makes this a true statement. It doesn't exist. There's never a case where I get y equaling 0, okay? So therefore, I just have an asymptote at y equals 0. I have a horizontal asymptote at y equals 0. So we've covered two things so far before I'm going to show you the graph of y equals 2 to the x. We've covered that we cross the y-axis at 0, 1, unless there's a transformation of some kind, all right? And then we have a horizontal asymptote every time at y equals 0. Now, this horizontal asymptote can move up or down based on transformations as well, just like this starting point can, or this crossing point is probably a better word, okay? So now the last thing is to realize is that since this b value, in this case is 2, that's larger than 1, we say this is an exponential growth. So the graph is growing when I look at it from the left to the right. So this is basically a quick sketch of what 2 to the x would look like. Okay? That's pretty much what it's going to look like. All right? So what if instead of 2 to the x, I did, what if instead of 2 to the x, I did 1/2 raised to the x power? Okay? Well, all these things are still going to stay true because I haven't had any transformations. All of these things are still going to stay true, but y equals 1/2 raised to the x power. Well, in this case, I'm going to put parentheses around the 1/2, just so you realize that 1/2 is not just 1 to the x, it's 1/2 to the x. Okay? Since the b value, which is 1/2 in this case, is less than 1, then that means that we call this an exponential decay. So it goes down from left to right. Now remember, we can't ever actually cross an asymptote. So I get really close and I basically say I'm going to continue going forever, getting infinitely closer, but I'll never actually touch it. And bam, this is what I'm looking at. This would be exponential decay. So we looked at exponential growth, we looked at exponential decay. Guys, that's 90% of the exponential function, all right, as far as like graphing. We haven't talked about solving one, and we will, not today, but another day, but that's 90% of the exponential function. So let's dive in and just do like one of your homework problems so that way you guys just have a little bit of something, a little bit more meat to work with here, okay? So let's look at something like problem 3. I'm not going to do all of the part of problem 3, I'm just going to do a little bit. It says g to the x is equal to 2/3 raised to the x minus 1, and then I'm going to do the first one with you, g at 1.3. Okay, so first off, this should not be a hard question, genuinely. It's not meant to be hard, okay? But let's interpret everything to make sure we understand what's going on. I have some function g, okay, and it's equal to 2/3, so 2 divided by 3, raised to the power of x minus 1. So first off, this is an exponential function because it's being raised to a power that contains a variable. Okay, it contains this variable, even though there's a minus 1, that's in the power 2. Since there's an x in the power, that makes this exponential. Now, the question itself is saying, what is g at 1.3? So all this is saying is, hey, plug in 1.3 for x. That's all it's saying. It's just saying evaluate the g function at 1.3. So instead of having x now, I'm going to plug in 1.3. So I'm going to say 2/3 raised to the 1.3 minus 1. And this is going to be some crazy number. I don't expect you to be able to do this in your head. So let's pull up a calculator and let's make that magic happen. Okay? So I'm going to turn this on. Okay, so put in parentheses, 2/3 raised to the... Now your calculators are a little bit nicer in the fact that it's actually going to like put it up in the power. I'm going to have to put mine in parentheses because my calculator otherwise won't recognize that all of this is supposed to be in the power. Press enter, and I get 0.885, and it says round your answers to 3 decimals, so the 4 would not bump up the 5, so the answer is 0.885. So the answer is approximately 0.885. Bam, that is it for the first question in G. The second question in G, G square root of 5. Okay, guys, same exact situation. Turn your calculator. Type it in, 2 divided by 3 raised to the second square root 5 minus 1. Close it, press enter. Boom. 0.60. Now that 8 is going to bump up that 5 to a 6. So 0.606. So this is approximately 0.606. Boom. That's all she wrote. All right, let's do one from the bottom 4 you have. All right, and I'll help you out with one of the weird ones, one of the ones with fractions. It's not really hard, but I know you guys hate fractions. So let's try doing problem 7, which is h of x is equal to 3 divided by 4 raised to the x. Okay, now we read the instruction. It says, please read and follow all directions. Use a pencil. Find the following for the given functions. Make a table of values for x being -2, -1, 0, 1, 2. Okay, so that's easy enough. X, y, -2, -1, 0, 1, 2. Okay, so let's use a calculator to figure out all these answers. Okay, so we're going to have 3 divided by 4 raised to the, all right, the first one was a -2, I believe. So I'm going to round that to 1.778. All right, 1.778. So that's just, that's just slightly above 1.5. It's 1 3/4 pretty much. All right, now I'm going to plug in a -1. Second insert, -1. So I get 1 1/3. So 1.3 repeating. 3, 3. All right, now I'm going to plug in 0. All right, so that's 3 divided by 4. Now you should already know what the answer is going to be because what is anything raised to 0 power? You should already be able, you should have just said, 1. All right, anything raised to 0 power is 1. All right, so we get 1. All right, now I'm going to do 3 to the 4th raised to the 1 power, which again, that's something, guys, that you shouldn't even need to type in. Anything raised to the 1 power is just that thing. All right, so 3 to the 4th raised to the 1 power, it's just 0.75, which is just 3/4. And now we're going to raise this to the second power. So second, press enter, and we get 0.5625, which is just slightly over 1/2. So first off, what do you notice my y values are doing? My y values are going down. Okay? My y values are going down. So that means, look at this b value. This b value is 3/4. Is 3/4 less than 1? Yes. So that means this represents an exponential decay. Very good. It represents an exponential decay. All right? So, we have an exponential decay. Okay, now, that was part A. Part B, sketch the graph, plot the points, sketch the curve. Okay, so let's plot the points. We're not looking to be great, we're looking to sketch. Okay, so 1, 2, 3. Actually, I'm going to make mine a little bit, because what's the highest y value I'm dealing with? 1.778, so I'm going to give myself a little more room. 1, 2, 3. So I say -2. 1, 2. So at -2, I was what? 1.778. So that's like, you know, that's 1 3/4. So probably about right here is fine. Again, we're sketching. -1, 1.33. So about right here is fine. 0, 1. And then it's 1.75. So that's, you know, 3/4 of the way up. 2.5. So that's just half of the way up. Okay. So first off, hopefully you're thinking back to the very first graph I showed you guys, the second graph, sorry. That was a decay. And so you know that this guy should be curving down, and I cross through the point. Now, don't make it go farther yet. Okay, first off, I'm sorry that I'm so bad at drawing, but don't make it go farther yet. Don't extend it farther past, because let's go ahead and think about, do we have our asymptote? Yes, this is an exponential function because there's a variable in the exponent, so we have a horizontal asymptote. Where is the horizontal asymptote located? Y equals 0. Unless there is some transformation that moves it up or down, then it is always at y equals 0. Okay, and there was no transformation moving it up or down, so it is just y equals 0. So we draw a horizontal asymptote. Now we can kind of finish sketching this guy out because we know it should. I'm so bad at drawing. Because joke. Okay, pretend this is getting infinitely closer and this is going infinitely up. Okay. And so then the next part says find the domain. Okay, let's talk about the domain here, guys. Domain is all possible x values from left to right. What is this guy doing to the left? What is this guy doing to the right? That's right, they're going on forever. So negative infinity to positive infinity. Of course, you could put that funky R saying all real numbers. That's fine with me too. Now it says the range. Okay, remember, range is lowest y value to highest y value. So what's the lowest y value taking place here? Well, hopefully you're like, well, I guess 0 is the lowest y value taking place, but I never touch 0. Right, so we're going to say 0, but we're going to give it a parenthesis because I don't ever actually touch the 0. And then we're going to go up to infinity. So we put infinity. All right, so there's our range. Last but not least is our asymptote. All right, which is just y equals 0. Beautiful. All right, now that's just how you're going to do each one of these questions. Guys, the only thing that's really going to change on some of these is that your graph is going to be going as a growth graph instead of a decay graph. All right. So, guys, let me know if you have any questions. Feel free to send me an email or remind. Have a great day.